that we get from the crystal. And we buy super expensive electronics to make sure we don't lose that information. How do we take in all of that data to make sure that we can collect the entire peak and not miss any data points if it's happening so fast? Think about that. If I wanted to take an hour's worth of data, but in order to get all the information I needed, I had to take a data point every half a nanosecond. Think about how many data points would add up over the course of a time as short as an hour. And then consider the fact that most of these experiments happen on the scales of days, if not weeks. This leads us into our question about the computer processing power and what kind of processing that we use to take in and analyze these signals. For the analysis step, where we take the signal from the detector into a system that gathers it and then puts it on a computer, we use what we call a data acquisition system, or a DAC for short. This is one of those data acquisition systems. This has 32 input channels, so it can take in 32 analog signals, and then it has a processing speed of 125 megasamples per second. So that means that for each of those 32 channels, it can take in and read a signal, and it can collect a data point once every 8 nanoseconds. And that may sound super fast, and it is super fast. This is a super expensive advanced piece of equipment. But once again, going back to the barium fluoride crystals, which can produce peaks that are less than a nanosecond wide, taking data once every 8 nanoseconds is going to completely miss most of those peaks. So even this board is not enough processing power to pick up the signals that we want to be able to read. For that, you have to have an even more advanced digitizer than this, which takes in the analog signal, runs some sort of algorithm or filter on the signal that you program into the board, and then spits out whatever parameters or results that you want, whether that be a raw signal or the energies of all the peaks that you see or the timing of all the peaks that you see. It has to be able to take in that analog signal, analyze it with enough granularity to pick out what you want, and then spit that out to the computer in some sort of list of data, which we can then go through and process. So you would need a digitizer that is advanced enough to take in that amount of data and take data points, multiple data points every nanosecond, to even be close enough to seeing what you want to see from barium fluoride. And those do exist, but let me tell you, they're very expensive, and they do not make them like this with 32 channels per digitizer. You would find one that maybe had 2 channels or maybe 4 channels if you were lucky. So yes, this detection technology has been around for almost 100 years now. The idea of a scintillator catching a particle, producing light, and then that light being amplified by a photomultiplier, that is not new. This is old technology, but it still works. Thank you for these very insightful questions, and please keep the questions